Today's video is Chapter 7, Lesson 1A and 1C. We're going to graph relations in 1A. This lesson has a lot of vocabulary words. Our first vocabulary word is coordinate plane. A coordinate plane is made when you crisscross two lines. So this whole picture right here is a coordinate plane. A coordinate plane is made up of four sections. Those four sections are called quadrants. And where they cross, right here in the middle, that vocabulary word is origin. The origin is the place where the two lines cross. This blue line right here is called the x-axis line. And the pink line right here is called the y-axis. So there's a sideways, a horizontal sideways line, and there's a vertical line. They cross at the origin. If I graph this pink dot, we need to have a way of saying what its location is, or address. So we're going to put parentheses and a comma, and we're going to go sideways first. So we're going to go on the x-axis sideways to 5. So the first number is always x. And then I'm going to go up and down, and I ended up at 2. The second coordinate is always the y. So you always travel sideways and before you go up. Okay, so your first question of the video is to tell me what is the ordered pair for this dot, the coordinates. What are the x and y numbers for this pink dot? Well, if you chose the option that said 1, 6, you are correct, because we want to go sideways to 1 before we go vertically to 6. Let's do another dot. This is going to be a weird one. What if I had a dot on the x-axis? What would be the ordered pair for that dot? Did you choose the correct answer, which was 4, 0? We're going sideways 4, but we're not going up and down anything. Your next vocabulary word is relation. A relation is when you have lots of ordered pairs, lots of dots, then we call it a relation. If it's just one, it is an ordered pair. Lots of ordered pair, it's a relation. And then how would you describe this relation? Does it make any kind of a pattern or any kind of a picture to you? I would say that it makes a straight line. That looks like a pretty straight line. Not all the time will they fall in order in a straight line. They could be zigzag, they could be crazy, they could be kind of curved, but they might make some sort of a pattern for that relation. We should also talk about a table. A table is just fancy for saying we're going to have a chart. And I'm going to have an x and a y, and I'm going to make a table for this relation. So I have one of my ordered pair is at 1, 6. Another ordered pair is at 2, 4. Another ordered pair is at 3, 2. And our last dot is at 4, 0. So a table has an x side and a y side, and it's just going to list all of the x numbers. The y column will answer all the y values, but if you read it sideways, they're like ordered pairs. So 1, 6 is like this dot right here, 1, 6. All right, let's move on to lesson 7.1c. We're going to talk about function tables. Well, I had said before that a table is just a fancy chart that has an x and a y side. This function table is going to be a chart. It's going to be a table, but it's going to have more pieces to it. It's not just going to have two sides. This table, because you can make a table out of anything, this table is going to have 3 parts. The first column is going to be called our input. It's still just x. Our final column is going to say output, and that's just fancy for y. The middle of the table is going to have a rule. It's going to have a function rule. It's going to give us some directions. What do they want us to do with x to get y. So if my rule is 4 smushed with x, that means I'm multiplying by 4. They will give you the first, the input number. So maybe they're going to give us the input numbers of 2, 5, and 10. They want us to use the rule times by 4, and over here is where they want us to give an answer. The middle column is the work. The last column is the answer. 2 times 4 is 8. 5 times 4 is 20. And 10 times 4 is 40. So they started off, the book will have the basic function table. They'll give us the input numbers, and they'll give us the rule. And then we're going to fill in everything else. All right, so here would be a question like the book. They're going to give us the input numbers, the rule. They want us to fill in the work, and they want us to fill in the answer. So the work is going to say 6 times 1 minus 3, 6 times 4 minus 3, and 6 times 8 minus 3. The rule says 6 times our input minus 3. 6 times 1, 6 times 4, 6 times 8. So then we're going to get our final answers. So 6 times 1 is 6, minus 3 is 3. 24 minus 3 is 21. 48 minus 3 is 45. All right, let's suppose they give us the output numbers, and we have to now find the input. Well, that sounds like working backwards to me. And when else have we started working backwards of PEMDAS? When we did equations. So I think we should say 2x minus 9 equals 11. And then we should actually solve that equation. 2x minus 9 equals 3. 2x minus 9 equals 9. And then I'm going to work it out over here because I need more space. 2x minus 9 equals 11. I'm going to add 9 to both sides and get 20. Rewrite and get 2x equals 20. Divide by 2 and get 10. So that means my input was 10. I would like for you to come up with the input for the next two. Type in your answer for the next two inputs. All right, did you find the answers of 6 and 9? Here's my work. 2x minus 9 equals 3. I added 9 to both sides to get 12. I divided both sides by 2 to get 6. I added 9 to both sides to get 18. I divided both sides by 2 to get 9. Your final question is, in your own words, describe input. What does input mean to you? I would have said the x value, or the number that you're starting with, or the number that you're sticking into the rule. Those would have been the ways I would have described input. All right, thanks for watching.